In this video, we're going to learn how to use perpendicular bisectors to solve problems. And look at this page. It's a little overwhelming, isn't it? The most important concept you need to know is this perpendicular bisector. And what that is a line that's perpendicular at its midpoint. So in other words, since we have been studying triangles, if you have a equilateral triangle and you can have a midpoint on AB, okay, and at that midpoint, if this angle bisector CM is perpendicular to AB, then we call CM the perpendicular bisector. In other words, it bisects AB and it's perpendicular, so it's two conditions. Equidistant is just a point that's the same distance to two figures. So you can say that Princeton is equidistant from Philadelphia and New York City. Concurrent is something like this. If I have, whoops, that wasn't very good. So if I have three lines or four lines that meets at the same point, that intersects at the same point. So if I can do this, that's better. I can say line A, B, and C intersect at point M, and they are concurrent. And M is called the point of concurrency. So, like I said, the most important concept is perpendicular bisector. We'll work through the rest of them in the remainder of this video. Here's a theorem and a converse. Perpendicular bisector theorem, you can guess it, the hypothesis is right there. If a point is on the perpendicular bisector of a theorem, then what's going to happen? Then this point is equidistant from the endpoint of the segment. Equidistant from the endpoints of the segment. In other words, look at our diagram here. It says CP is the perpendicular bisector of AB. So then obviously P is the midpoint of AB, then CA has to equal CB. If I have another point in the middle here, I can call it D, and then the distance between D and A and between D and B is the same. So DA equals DB as well. So that applies to all the points on this perpendicular bisector. Okay, and then the converse is that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. Bisector of the segment. So in other words, in this diagram, if DA and DB are of the same length, then D, this point D, lies on the perpendicular bisector. Bisector of AB. And the perpendicular bisector of AB looks like is CP. Okay? Here's an example. As convoluted as these theorems are, when you use them in actual examples, it's really helpful and it makes life a lot easier because they're very powerful. So here it says AC is the perpendicular bisector of the segment BD. So in other words, immediately I know it's telling me C is the midpoint and I've got a right angle right there. So it's very useful when it gives us information like that. And also by perpendicular bisector theorem, I also know that AB and AD must be congruent, must be of the same length, right? So it's asking me to find the length of AD. So let's go. as I mentioned, by perpendicular bisector theorem, AD and AB equal each other. And on the graph, it tells me AD is 4x and AB is 7x minus 6. And then with a little bit of algebra, if you know your algebra well, you should be able to solve for x equals 2. And then you plug x back into 4x because AD is 4x. So I should have 4 times 2, which gives me the length of AD is 8. Okay? Again, one theorem takes care of everything. It's really powerful. Second example, in this diagram, KN is the perpendicular bisector of JL. So JL right here. A, what segment length in the diagram are equal? And B, is M on KN? Okay, so let's see how do we answer these questions. KN bisects JL. KN bisects JL. So NJ and NL equal each other. And because K is on the perpendicular bisector of JL, therefore KJ, right, would equal KL by perpendicular bisector theorem. So because, and then the diagram shows that MJ and ML equal 13. So I think that's what I got, right? So I got NJ and NL equal each other. I've got KJ and KL equal each other. And I've got NJ, I'm sorry, I wrote NJ and NJ. NJ and ML. Whoops. Making a bigger mess. Here we go. So this should be ML. And they equal each other. Okay. So now for B, because MJ equals ML, M is the equidistant, from J and L. And if you write here, M is of equal distance to J and L, that's totally acceptable. Equidistant obviously is sounds a little bit more snobby. Because that's what mathematicians use. But if you write equal distance, explain the meaning of it, I will certainly accept it as a correct answer. So by the converse of perpendicular bisector theorem, M is on the perpendicular bisector of JL, which is KN. So the answer here is converse of perpendicular bisector theorem. Okay. Here's a checkpoint. Make sure you complete this by yourself. Okay, concurrency of perpendicular bisector of a triangle states that the perpendicular bisector of a triangle intersects at a point that's equidistant from the vertices of the triangle. So in other words, look at this diagram. If notice that P is my point of concurrency, right? Because all of these perpendicular bisectors concur at one point, and that one point is P right here. And because of that, so PE, PF, so PE, PF, PD are my perpendicular bisectors of all the sides. 1, 2, 3, 1, 2, 3. That's what I know. And by this theorem, I also know, I'm going to use blue, PA. Notice it's PA, not EA. PA, PB PC, this is just one marker, are congruent to each other. So PA, PB, and PC equal. They equal each other. Let's see how we can use the concurrency of perpendicular bisectors. Here's an example. It says that you have three friends, A, B, C, on the football field, and you want to find a spot for yourself to stand, and that spot has to be equidistant to all three of your friends. So let's see how we can work this out. Now, the concurrency of perpendicular bisectors shows you that you can find a point that's equidistant to all 3 points. So we're going to use that. If we use that, we have to use the perpendicular bisectors. Perpendicular bisectors of the triangle formed by these points. So now I copy down this position down in this diagram. I have my friend, let's see, A, B, C right here. Those are my three friends. And I have to find a spot that's of equal distance. So D would be my spot. And the way to do it, as we mentioned earlier, is that we have to find the midpoint of AB, find the midpoint of AC, and find the midpoint of BC. And then we have to draw perpendicular lines to these segments. And that's how you finally found your point D. Okay, so you have to use a ruler and a protractor to draw the three perpendicular bisectors of ABC. And then that's how you find point D. Again, draw the triangle ABC, like what we do right now. So if I have ABC, then use your ruler, find your midpoint, 2, 3. And then from your midpoint, you draw your perpendicular line like that. And where these three perpendicular line meets, that's point D. That's where you want to stand. And at point D, you'll be of equal distance to all three of your friends. You are the center of attention right there. Okay? All right, good luck, guys.